Hello everybody, welcome back to Human Resource Machine. I want to start today by revisiting Multiplication Workshop. This one gave me quite a bit of trouble. It took me almost 2 hours to do everything, including the bonus. But today I want to get some revenge because I came back with a new idea. So previously, we have always been initializing sum with 0. But I figured this is not necessary and we can improve on that because we have already tested that both of our inputs are not 0. So by the time it gets here, we are guaranteed that we are adding at least one time one of our inputs. So in this case, we have, let's see, input 1 is the smaller number. That's the one we use for count. And so we can start by adding a copy of input 2 into sum immediately. This will initialize the sum to one time the input. Besides that, we need to, this subtraction is not going to work immediately because we need to be holding 0 in our hands before doing the subtraction. And after this, we also want to bump this number up by 1 because we have already added one time this to the sum. One more thing that we need to do is jump if 0 over here to skip the entire loop because we've essentially done one iteration of the loop up here. So that leaves the possibility that in 1 might be 0 at this point, and we don't want to enter this loop at all if that's the case. For the other branch, I'm going to do the same thing. This one is where in 1 is the number we want to add, and in 2 is the counter. So I want to bump that up as well, and also add a jump if 0 to skip the loop. Last thing, this part can also be improved because in this branch, this is when the first input is 0. We used to be doing this, which is in, copy, out, jump. That's 4 instructions. We could remove this. We could send the 0 that we're holding to outbox right away and then get another one from the inbox. After that, we'll jump right back to the beginning and trash the other number, get new numbers from the inbox. So that only requires 1, 2, 3 instructions to go back to the beginning, which saves one more instruction. With that, I think we should have a pretty good improvement this time. Hooray! See, last time we barely made it to 109. And this time we were able to save 7 additional steps. So that is great. Alright, let's continue. Next one is 21, 0 terminated sum. Yes, we believe in educating our employees on the job here. Do you know what a 0 terminated string is? Yes, I do. Yes, it is a very old technique and we don't expect you to know. So you may ask me about it if you like. Or you may ask an external source, whatever helps you get the job done. Okay, so inbox is filled with 0 terminated strings. What's that? Ask me. Add together all the numbers in each string. When you reach the end of a string marked by a 0, put your sum in the outbox, reset, and repeat for each string. Yeah, so basically here we have 9700, 0 is the end, so we need to add 9 and 7 together. The next one is 5 minus 5, 5, 0. 0 is again the end, so we add 5 minus 5 and 5 together. So we need to keep track of our sum somewhere. And in order to add things, we have to have stuff on the floor. So get a number from the inbox. Let's copy it to this slot, and this slot will be our sum. So this will give us the first number as the sum. Okay, there's a slight problem, which is if our current number is already 0, then we want to immediately output 0 to the outbox. And this is when we jump back to the beginning. Now, if our first number is not 0, then our sum is something. So now we need to pick the next number from the inbox. And this time we do not copy it to sum anymore. Instead, we need to add the previous sum. Put this number back into sum. Okay. Yeah, and we need to test if the new number is 0. And if the new number is 0, then we just want to pick up the sum that we already have, send it to the outbox. If it's not 0, then we write the new sum, and we go back to picking the next number. I think so. Okay, I need to work on both the size and the speed. I think I found a couple of things. First of all, this jump if 0 can go before copy 2, because with this jump all we're doing is putting a 0 in the outbox, so there's no reason to write anything in memory. So we can, if we do this, every time the string is just a 0 without any numbers to add, it can save one instruction. The other thing is we have copy to sum here, and we also have copy to sum here. And this jump brings us right below copy to sum. So why not just delete this one from here, and by the time we jump up here, we do this copy to sum. That reduces the redundancy and saves one instruction. Let's try that. Hooray, we got both. Number 22 is Fibonacci Visitor. This back hallway's for advanced employees only. Are you sure you want to be here? These night shift assignments are optional, you know, and they are difficult. If you need to ask for help, I'll just be here looking through these catalogs for a golden spiral. For each thing in the inbox, send to the outbox the full Fibonacci sequence up to but not exceeding that value. Okay, for example, if inbox is 10, outbox should be all the numbers that are less than or equal to 10. What is the Fibonacci sequence? I know that. So usually you'd want you'd want 3 cells to do the addition. This is the first number is the second number, you add them together, and then you shift everything off by 1 and you repeat the addition. That's how you do Fibonacci normally. So I'm gonna need to get a number from inbox and then store that in some slot so that I can use that number to compare later. Okay, and then to initialize the Fibonacci sequence, I'm going to want to get a 0, and then I'll copy it to here. I'll also copy it to the second slot. Let's do all 3 slots, except I want this slot to have a 1 to kind of bootstrap the entire process. So I'm going to bump this slot up by 1. So by the time this finishes, you have 0, 0, 1. And then for the looping part, so right now I will be holding the value of this square, which is the first Fibonacci number, that's the 1 here. I'm going to need to compare that with the number in my input. If it's negative, I need to be careful because it's possible that they're equal, and I need to make sure the equal case is handled properly. So if this is negative, that means this number is strictly bigger than that. Yeah. So if it's negative, we are still good to output a number. If it's 0, that means the two numbers are equal, and we are also good to output a number. Otherwise, we should not output any more. If the result is positive, it means our Fibonacci number is now greater than the input, which means we need to stop this loop and go back to getting the next input. Okay, over here is where we're outputting our Fibonacci number. So we send what, nope. We need to copy from the number again, because at this point we've destroyed the number, we've done the subtraction. So we get the number again, send that to outbox, and then we need to shift all the numbers. So let me do copy from 1, move that over to 0, copy from 2, move this over to 1, which is also going to our outbox. And then I will need to, okay, I guess we need to copy from 1 again because we've just lost the value. Add 0 and store that result in 2, so that 2 has our next Fibonacci number and is also in our hand, which means we can now do the jump back to here. Yeah, or we compare the number and see if it's safe to output. Let's try it. Okay, we're actually pretty close to the challenges. We just need to reduce by 1 command and a few steps. Alright, so when I was working at it last time, I had concerns about this jump if negative, jump if 0, jump, because we had to pay attention to the case where the two numbers are equal, and we don't have a jump if positive instruction. So if we reverse the order of subtraction, instead of using the Fibonacci number to subtract the input number, if we did the subtraction the other way, then we can simplify this jump logic a lot. So let's do that. Instead of getting the inbox in front, I want to get the inbox after initializing all the Fibonacci numbers. So this is where we set up the 001 here. Now we take the inbox, copy it to slot 5, but also subtract our current Fibonacci number. And this time, if it's negative, that means our Fibonacci number is bigger than the input, and we can jump directly to the beginning again and skip all the loop. And then we don't actually need either of these jumps. That's gonna reduce some instructions. And then over here, by the time we send the next Fibonacci number to the outbox, we also want to copy from our input again. so that by the time we get up here, we're holding the input number and we're subtracting the next Fibonacci number, so that the test can test if we've exceeded the limit again. I think that would be right. Yeah, okay, now we got our size challenge, but our speed decreased. So now we need to fix our speed, but we don't need to worry about our size anymore. So we're back at the previous solution with the multiple jumps, because that one happened to be faster. It took fewer steps to execute, and we're going to use this as a basis to optimize our execution speed. So one thing you can notice is that every sequence always starts with 1, 1, 2, 3. These numbers are very easy to calculate, and so we can consider unrolling some of our loop, just the first few iterations of our loop, so that we can easily calculate these and easily determine if these initial numbers need to be sent to the output. So I'm going to put a little divider here, because I'm going to start making things on top. So the first thing we need to do is get a 1. So let's copy from this. In order to bump, I'm going to need a number on the floor. So, wait, actually, there's nothing that says I can't modify this one. So I'm going to bump this up to a 1. And then I'm going to get the inbox number and still copy it to 5, because I'm going to need it for later iterations of the loop, even if I don't need it immediately. I am going to subtract this. Okay, and that is the right order, because if the result is negative, that means my inbox number is smaller than 1, which means we shouldn't output anything. We should go back to the beginning. Now, if it is not negative, that means we are safe to output the first 2 1s. And so the 1 is stored in here, so I'm going to copy from here. I'm going to send it to the output, make another copy, and send it to the output again. As you can see, we already got our first 2 outputs in just a few steps without going through this entire loop twice. So that already saves many, many steps. I think I'm gonna set up my calculations using this as a start. So I'm gonna put, instead of 0, 1, 1, I'm gonna put 1, 1, and 2, where 2 is the next Fibonacci number I need to output. So around this point, I'm already holding a 1, so I'm going to copy this to here, copy to here as well. I'm going to make another copy here. After I output, I'm going to bump this one up by 1, so that this becomes 1, 1, 2, and we can get on to our regular loop without having to do all of this. So now we have bumped this to a 2, we subtract the number to see if we should output a 2, and we get on to our regular loop. Yeah, let's try it. That outbox. How did 2? Oh. Okay, yeah. Okay, turns out we do need to be careful when we bump that. How about we bump it only once in the beginning? Because we definitely don't want to be bumping that in a loop. Oh yeah, we did very good. Number 23, the littlest number. To reduce our carbon footprint, management is requesting the smallest numbers only. This is a public relations exercise. The results are going straight to the landfill. For each zero terminated string in the inbox, send to the output only the smallest number you've seen in that string. You will never be given an empty string. Reset and repeat for each string. Okay, we got the zero terminating, so we will never be given an empty string. That's a good thing. So we take the inbox. This is our first number, and by default, so let's say this is our smallest number. So by default, the first number we get is always the smallest we have so far. So I'm going to put this right here. That's this start. And then I would take another number from the inbox. That's the next number. I am going to subtract. Wait, let me store that before I destroy it. Copy to slot number 1. This is where we store our current. Number. Take our current, subtract the smallest. And if this number is negative, that means the smallest is actually bigger than the current. Yeah, the smallest is bigger than the current, and so we need to take the current and copy that into the smallest. So the current one becomes the smallest we have so far. If it's not negative, that means we don't need to do anything. Come out here. Now there is another problem, which is it's a zero terminated string. So we need to test if it's 0. If it's 0, we just skip this entire thing and copy from smallest and send it to the outbox. Set up the master loop here. I know I'm forgetting a lot of stuff. If it's 0, get the current smallest numbers into the outbox. Okay. If it's not 0, you test the next number. If it's negative, you do this. If it's okay, but you need to also jump back to here so that you get the next number. Okay, let's try it. I don't think the 0 is working. Yeah, something's wrong with jump if 0. Oh, okay, no. This needs to, this needs to go down one step. Must have messed up the positioning of this jump instruction. Okay, now it's doing the right thing. Okay, we need to reduce by 1 instruction and work on the speed a little bit. So there are a few things we can do to improve this. The first one is this jump if 0 branch. It comes down here, so it has a jump instruction, a copy, an out, and another jump instruction to go back to inbox. So the whole process takes 4 steps. But if we do the trick that we had before, where we move the output instructions to the top, then this jump only needs to come to the top, and we can avoid having an extra jump at the end. This saves one instruction every time the input is 0. So we don't need this jump anymore. but we do need to add one jump instruction here just so that initially, for the first time ever, we don't start with a copy from smallest in outputs. We start with the inbox. The second thing is, over here. Jump over here, and then it immediately jumps over there. This is pointless. We can just set the jump target to here immediately, so it saves one jump instruction per iteration of the loop. The next thing that we can do is, here we have been copying the value to memory and then restoring it later. And the reason for that is because when we do the subtraction, we're going to lose the value in our hand. But there is actually another way to restore the value without storing it and reading it back from memory. That's because if we take a value from inbox and then we subtract the smallest, to restore the number, all we need to do is add the smallest back. So if we subtract the number and then add the number back, we're going to get the original number. So let's go with that and see what happens. Hey, we got both challenges. Number 24 is mod module. How many hours of work can you fit in one day? Not enough. There's always a sad remainder of unworked hours. Good thing we have these optional night shifts to cram in more. Right. For each, two things in the inbox outbox the remainder that would result if you had divided the first by the second. Don't worry, you don't actually have to divide, and don't worry about negative numbers for now. Okay, so basically 6 and 2, so if you divide 6 by 2, you get 3 with no remainder. So without dividing anything, basically what you have to do is you take 6 and you keep subtracting 2 until you end up with a number that's less than 2. Alright, so let's take our first number. Let's store that here. Let's take our second number. I think we also need to store it, so let's put that in the next slot. Okay, now let's do a sub. So if we're taking that one, if we're taking 2 and subtracting 0, that means we're taking the number that we're dividing by and subtracting the remainder. Okay, so if it's negative, that means the remainder is bigger than the number, which means we need to subtract. If the result is 0, that means the remainder is equal to this, and so we still need to subtract. If none of this is true, this is when we need to, let me put a note here and just say sub. So this is the place where we would execute our subtraction. And then here is after we finish all the subtraction and we have a remainder that's less than this number. This is when we need to get the number from here and send it to the output. And then do our master loop over here. Now for the subtraction part, we need to take this number and subtract this number, put it back into this number. After that, we will need to jump and oh, that's kind of awkward because over here we end up with slot 0 in our hands, and over here we end up with slot 2 on our hands, so we're not doing the subtraction. So let's actually do this. Copy from 0, so we end up with slot 0 in our hands, and we're going to subtract 2 each time. And this makes our comparison easier too, because we don't need to do that. All we need to do is jump if negative. If it's negative, it means our remainder is already strictly less than our divisor, and so we can go down here and output our remainder. And after we do this, we jump up to here because we're holding slot 0 in our hands. Just like from here, we're ready to subtract. Okay, I think that should be good. Do we need this copy from 0? Because yes, because we get here after subtracting, so we're not going to have the right value in our hands. Okay, let's go. Okay, not bad, but we need to optimize quite a few things. You know what? For this one, let me delete the entire program and start over, because I'm going to use a totally different logic now. So once again, I'm going to take the first number, copy it to this. I'm going to take the second number and copy it to here. Now I'm going to grab my first number back, and I'm going to keep this in my hand from now on without updating this slot at all. So what I'm going to do is I'm going to subtract the divisor, and I'm going to test if the result is negative. If the result is negative, we're going to worry about that later. But if the result is not negative, I'm going to go back and subtract the divisor again. So if I start with 6, I'm going to subtract 2. I'm going to have 4 in my hands. I subtract 2 again. I'm going to end up with 2. I subtract 2 again. End up with 0. Subtract 2. Now it's negative 2. And this is when this condition kicks in. So when it's negative, we are going to add the divisor back in order to make the result back into positive. So negative 2, that means we've gone too far. And so we're going to add 2 back to get 0. And that will be our remainder. So send that to the outbox and jump to the beginning. Yeah, this does very good. Sometimes it's not about the little tricks that matter. It's actually having a totally different concept for how you're going to write the program. Okay, I think this is pretty good for one day. We didn't get stuck on any super hard challenges this time, but it was still very fun. We'll continue with number 25 cumulative countdown next time. Thanks for watching. See you next time.